Hello, this is Tyler Beamer. This is an instructional math video for DMA 050. The purpose of this video is to show students once again how to write linear equations given points on the line, and also how to write equations of lines that are parallel and also perpendicular to other lines. So this is from Section 9 in Module 5. So go through a variety of examples to guide you through your homework. So here's the first problem we want to work on. Write an equation of the line passing through the given points 7, -4, and 2, 6. You actually did problems like this in Section 7, so this is a little bit of review, but keep in mind that two things that we need to write an equation of a line is slope and y-intercept. So we can find the slope between 2 points once again by using our slope formula. I'm going to go ahead and label our coordinates. Alright, so now substitute those values in, being careful with your signs here. So we get +10 on top, -5 on the bottom, which is going to give us -2 for our slope. Alright, so now that we have our slope, we want to then begin to write our equation in slope-intercept form. We want to use one of these points that are on the line. It doesn't really matter which one we use since they're both on the line. I'm just going to use the first one, and we're going to use that slope and that point into our point slope formula, which remember looks like this. So I have m, which is my slope. I have x1, which is the x-coordinate of my point. And I also have y1, which is the y-coordinate of the point. Being careful with signs. Got double negatives, so those are going to turn to positives. Distribute the -2 through the parentheses. I want to put it in slope-intercept form, so let's solve it for y. So then I'm going to subtract 4 from both sides. And so the slope-intercept form is y equals -2x plus 10. So -2 is the slope, +10 is the y-intercept. And then if we want to put that in standard form, remember we just want to bring this x term to the other side, so do the inverse, so add it to both sides. And we get (2x plus y equals +10). Alright. So like I said, that's a bit of review, but there are some of those problems still in this section, and of course having more examples to go by is probably a good thing. Alright. Here's the next type of problem that's in this section. We've got write an equation of a line through 3, 8 that is parallel to y equals 4x minus 2. Alright, so let's just think about what this is graphically. So let's look at a graph here. Here's the point 3, 8. Okay. And then we can graph the line y equals 4x minus 2 pretty easily since that's already in slope-intercept form. So -2 is our y-intercept. Okay, so we know that our graph's going to start there, and my slope is 4, so that means I'm going to rise 4 from the -2. So 1, 2, 3, 4. and then I'm going to run 1 to the right since the slope is positive. Okay, so if we graph that line, it's going to look something like this. And so what we want to do is we want to create an equation of a line. Let me zoom back out here. Create an equation of a line that is not only going to go through this point, but is going to be parallel to this line. So one thing to keep in mind to remember is that parallel lines should not intersect. Therefore, this line here is going to look something similar to this, and I'm going to draw it dotted or dashed. Alright, so we're trying to come up with the equation of that dashed line, right? Because that dashed line meets both criteria, right? It's parallel to the solid line, so it's parallel to y equals 4x minus 2, and it also goes to the point 3, 8. So if we think about this graphically, that is what we're trying to accomplish. Okay, so let's do that analytically using our point slope formula. Okay, so one thing that we know about parallel lines is that, like I said before, they do not intersect, and the reason why they do not intersect is because they have the same slope. So we know that this line has a slope of 4. Therefore, the slope of the line that we're going to write the equation of should also have a slope of 4, and it's going to go through the point 3, 8. So we have enough information to use point slope formula. Okay, so this is our x1, y1. So y minus y1, which is 8, m is 4, x minus x1, which is 3. And now solve this for y, so I'm going to distribute the 4 through. Add the 8 to both sides. So in slope-intercept form, we get y equals 4x minus 4. Alright, and we're just going to keep it in that form. And so if we look at the dotted line that we drew, alright, and we look at slope and y-intercept, right? Here is -4, and of course our line does go through -4, and it does have slope of positive 4, up 1, 2, 3, 4 over 1. All right, so we can verify that our equation actually is parallel to the one given graphically. Okay. Another type of equation that you'll see here in this section is basically the same type of problem, but with perpendicular lines. So write an equation of a line going through -4, 8 that's perpendicular to 2x minus 3y equals 1. So one thing that we want to determine once again is the slope, and notice this is not in slope-intercept form. So first thing that I want to do is actually solve that for y. So I'm going to subtract 2x from both sides, divide everything by -3, and that's going to give me this. And so basically y equals 2/3 x minus 1/3 is the same as this equation. It's just in slope-intercept form, and that allows me to identify the slope of that line. So that's helpful because I know that if I want to write a line that's perpendicular to that, then my slope needs to be the opposite reciprocal, right? So then the opposite reciprocal of 2/3 means that I'm going to meet two criteria here. It's going to have the opposite sign. So instead of positive, it's going to be negative. And then this fraction is going to be flipped. That's the reciprocal part. So the opposite reciprocal is -3/2. And that's the slope that I want to use when I write my line. Okay. So let's take a look at this graphically. Once again, our point was -4, +8, which is located here, and the line that we're writing our equation perpendicular to is 2/3 x minus 1/3. That's a little hard to graph, but here's minus 1/3 roughly for the y-intercept. So up 2 from there and over 3. So somewhere in here lies our line. That we want the equation that we're going to write to be perpendicular to. So one thing that we know or should know about perpendicular lines is they meet to form a 90-degree angle. So if our line needs to be going through the point 3,8 and then needs to be perpendicular to that line that I just drew, it's going to look something like this. So the dotted line kind of gives me a sketch of what my line's gonna look like. Alright, so notice that this dotted line, that's the line that we're writing the equation of. It meets both criteria. It goes through -4,8 and is perpendicular to this line, which is the 2x minus 3y equals 1. Alright, so let's write the equation of that dotted line. So we're well on our way. We've got the slope using the opposite reciprocal. So now we can use point slope since we have a point and we have the slope. So point slope, remember, looks like this. Here's my point. So I'm going to plug those values in here for x1 and y1. I'm going to put the opposite reciprocal that we found for our slope. That's what we need. And subtract -4. So once again we got double negatives here, so those are going to turn to positives. Then we want to distribute the -3/2 through the parentheses. And so when I multiply -3/2 times 4, I'm just going to show some side work over here. I can write 4 as a fraction 4/1. So basically that gives me -12/2. Multiply the numerator and the denominators, and then divide to give me -6. Okay. And then last step is to add 8 to both sides. And that should be our equation in slope-intercept form. And we're going to leave it in that form so we can compare this graphically. So if we look at our dotted line, are we close? Right? So we're fairly close to this y-intercept of 2, and obviously we've got a negative slope. It looks like it's about the right slope, 3/2. This is a sketch, so it's obviously not going to be exact, but it should match pretty well. All right. And then last but not least, I want to do these two problems. These two problems seem to stump students a lot of times, so I'm going to work on these here with you guys. So once again, write an equation of a line through this point, 4, -6, parallel to x equals -2. So let's just think about this graphically. Let's plot the point. For -6. So that point is here. Okay. And let's write or draw the line x equals -2. So remember that if we have a line or an equation such as x equals a constant, that's going to be a vertical line, right? Where every x coordinate of the points on the line is -2. So that's going to be a vertical line going through -2. So x equals -2 looks like this. Okay, so the problem says, hey, find the equation of a line that is parallel to this line and goes through that point. Well, the only way that's going to happen is if I draw another vertical line through that point. That's the only way that those two lines will be parallel and not intersecting. So then what's the equation of that line? Well, it's a vertical line. So I know it's going to be x equals some number, some constant, and that number is going to be where that line crosses the x-axis, which is 4. So x equals 4 would be the equation that goes through that point. 4 -6, and it's parallel to this line, x equals -2. So there's not a lot of arithmetic or solving involved here. It's just thinking about that type of problem graphically. It involves a little bit more critical thinking. Alright, so let's look at another type of problem that's similar to that. Once again, write an equation through 1, -5, in this case perpendicular to x equals 3. Alright, so let's once again think about that graphically. So let's plot the point -1, -5. So -1, -5 is going to be here. Okay. And let's graph the line x equals 3. Once again, that's going to be a vertical line going through 3 on the x-axis. Easy to graph. Okay, so in this case, I want to write or draw a line that's perpendicular to x equals 3 and goes through that point. Well, we know that perpendicular lines have to intersect to form a 90-degree angle. Therefore, the only way I could draw that perpendicular is if this was a horizontal line. So that line's going to look like this. Alright, it's going to go through the point -1, -5, and it's going to intersect the line x equals 3 to form a 90-degree angle. Alright, so then we just need to come up with the equation of that line. Well, since that's one of those special lines that is a horizontal line, alright, then I can quickly write that equation. That's going to be y equals, remember, y equals a constant is a horizontal line, and the number is going to come from where that horizontal line crosses the y-axis, which in this case is -5. So that would be the equation that we're going to look for. Alright, so hopefully these examples help you. If you have any questions, as always, please email me those questions. Feel free to use the Ask My Instructor button on the My Math Lab, or come by office hours. Have a great day.